Hey everybody, what's up? Mr. Miller here. We are going to now be looking at properties of logarithms. We started our journey with logarithms a couple days ago. We looked at how do we convert from an exponential equation to a logarithmic equation and the other way around. What we're going to do now is extend this and look at properties of logarithms. By the end of this video, we're going to be able to do the following things. You'll understand the properties of logarithms. You're going to be able to write expanded logarithms as single logarithms. Sometimes we call that a condensed form. And then we're going to write single logarithms as expanded logarithms. So we're going to be taking something that's compact, condensed, and we're going to expand it and make it longer. All right, so here are our logarithmic properties. The first rule is the product rule. And what this is saying is if you are multiplying two things and then taking the log of it, you can get the same answer by taking the log of each thing and then adding those two things together. The quotient rule is saying if I'm taking the log of something taking the log of something over something, I can get the same answer by taking the log of the top thing minus the log of the bottom thing. And then the last rule that we're going to be looking at is the power rule. And the power rule is saying I can either take care of the power first and then do the logarithm of whatever that ends up being, or I can do the logarithm of x and then multiply that by whatever the exponent was. So the exponent we can slingshot down, take the logarithm of whatever x is, and then multiply this result, whatever it happens to be, by the exponent p. These rules will get easier as you use them, but in the beginning it might be a little frustrating because you're going to be given problems where you might have to apply one or more of these rules, and it's important not to get frustrated. We need to just take our time, take a breath, relax, and eventually I promise you things will work out. So let's go ahead and look at some examples. Let me make sure I have the right screen up first. I think I do, but it's always good to double check. And all right, we are in business here. Okay, so what we want to do is make this full screen first of all. Okay. And we're just going to do some examples now demonstrating those logarithmic properties that you saw on the last slide. So I hope you wrote them down. If you didn't, please go back and write them down because we're going to be using them. All right, so let's get our first example going. And the directions are going to read something like this. Condense each expression to a single logarithm. All right, so here goes our first problem. Let me say example one. All right, suppose you're given something like this. 3 times the log of base 4 of 2 minus 3 log base of 3. That looks really sloppy, so let me make that a little bit better. Base 4 of 7. And what we want to do is we want to take this expanded logarithmic form and we want to condense it so we're only writing the word log one time. So we want to take some steps, work our way down, so eventually we have log base 4 of something. Right now we have 2 logs to worry about. So let's think about some rules that we can use. The first rule that we can use, right, is the power rule. Because I can take this 3 and I can slingshot it back up to the top to now have log base 4 of 2 to the third power. And I can do the same thing with the second logarithm. I can slingshot that 3 that's in front, 7. And we can rewrite that as log base 4, 7 to the third. The problem is we still have the word log written twice. We need to condense that so it's only written once. So what rule can we apply now? Well, we have a subtraction symbol, so I'm thinking maybe we could use the quotient rule. Product rule would be if this were a plus in between. Quotient rule is going to be if we have a minus. So I'm going to have the log of the first thing over the log of the second thing. But we only need to write the word log once. So I'm going to have log base 4, and we're going to have 2 to the third up top over 7 to the third on the bottom. And there you have it. Here's our answer. We've done what the problem asked. We've written it as a single logarithm. The word log is only written one time, and we are told this is finished. All right, why don't you guys have a try with this next one? What do I want to do here? Let me see if I can I use the cursor to, be nice if I can somehow scroll down, but I'm not sure how to do that. You know what, I'm just going to write it over here on the right side. Okay, so try this one. After you write it down, pause the video, work it out, and then check your answer against mine. It's 30 log base 7, 8, plus 5 log base 7, 3. Pause the video, try to work that out. Hit play and check your answer. Okay, the first thing we notice is we have numbers in front of the log, so we can slingshot those back up. That's using the power rule. So if I do that, now I'm going to have log base 7 of 8 to the 30th plus log base 7 of 3 to the 5th, right? So all I've done is taken that number in front of the log and I've slingshotted it back up. Now, what do we have in between the two logs? We have a plus symbol. Plus product, both start with P. Product means to multiply. What this is telling us is we can condense these two things into one logarithm by multiplying 8 to the 30th, parentheses, 8 to the 30th, times 3 to the 5th. And there you have it. We've written it as a single logarithm. And we are finished. There's really nothing more that we can do with that, nor would we want to, because 8 to the 30th is going to be a ridiculously big number. All right, we're done. All right, now let's look at going the other way. Let's say that you're asked to take a condensed logarithm and now expand it, make it longer. Let's look at how we would do that. So the directions are going to read something like this. Expand each logarithm. All right, so let's say that you're given something like this. Log base 6 of 3 to the 6th over 2 to the 6th. and we want to expand it. So now we want to take that single logarithm that's in our problem, and we want to try to rewrite it so we have the word log in there more than once. Well, notice that we have a fraction. That's a quotient. That means we're dividing. So we can use the quotient rule right off the bat. And the quotient rule says the log of something over something is going to be the log of that top something minus the log of that bottom something. So I can rewrite my problem as log base 6 of 3 to the 6th minus log base 6, 2 to the 6th. We have to stop there and ask ourselves, is there anything more that we can do with this problem to expand it? And the answer is yes, because we have these powers in the corner, and they just happen to both be 6. That doesn't always have to be the case. This could have been 4, that could have been 1, or well, 1. Let me say 5. So they don't have to always be the same, necessarily. So let's apply the power rule now, and we're going to slingshot those exponents down. The 6 is going to slingshot down in front. This exponent is going to slingshot down in front. And now we're going to have 6 log base 6 of 3 minus, slingshot that 6 down, 6 log base 6 of 2. Finito. Beautiful. All right, now what I want you guys to do is have a go with this next example. Sorry, the microphone's brushing up against me. And have a try with this. Write it down, pause the video, work it out, and then check your answer. Log base 7 of u over v to the 5th, and this is all being raised to the 4th power. Pause the video, have a go with that. Okay, so the first thing that we can do is we can slingshot this 4 down in front of our logarithm, right? Nothing wrong with that. We can bring that 4 down. So we're going to have 4 log base 7 u over v to the 5th. All right, now what? Well, again, we have a quotient, and a quotient means to subtract. I can subtract the log of the first thing minus the log of the bottom thing. So now I'm going to have 4 log base 7 of u minus, now I have to be very careful here because I have this 4 in front of the log. That 4 is going to carry second log also. 4 log base 7 of v to the 5th. And now I ask myself, is there anything more that I can do with this problem? And the answer is yes. There's one more thing that I can do, and that's I can, again, since I have a power, I have an exponent here, I can slingshot down in front of the 4, and the 4 and the 5 are going to get multiplied together in this second part. Log base 7 of u. Oh my word, I'm just making it worse. Okay, sorry for that. Let me try this again. For log base 7 of u minus, when I bring that 5 down, it's going to multiply by the 4, which is going to give 20 log base 7 v. And we are done. That's the final answer. All right, so at this point, I'm done with presenting, but there is one more thing that I'd like to show you if you're interested. There's a second way that we could have approached this example 2 problem, and I'm going to show you that very quickly. What we could have done from the beginning is we could have, instead of slingshotting this 4 down, we could have applied the raising a power to a power rule. These are properties of exponents, and I can distribute this 4 to each piece inside the parentheses. So that would give us log base 7. 1 times 4 is 4 to the 4th. Distribute the exponent to the exponent in the downstairs. 4 times 5 is 20. So we get b to the 20th. And now what I can do is rewrite this single logarithm as a difference. So I would have log base 7 of u to the 4th. And I'm going to try to I'm going to have to erase example 2 so I can demonstrate this. Eraser. But I want to keep the final answer up just to show that you would get the same thing. Okay, let's do it. Okay, so now I'm going to get log base 7 u to the 4th minus log base 7 v to the 20th. And now if I apply the power rule, I can slingshot the 4 down, I can slingshot the 20 down, and that's going to give us exactly what we have in the box. We're going to get 4 log base 7 of u minus 20 log base 7 of v, and you can see that matches exactly what we got before. So there's 2 ways we could have done example 2. Okay guys, I hope this video was somewhat helpful. We're going to do more examples in class. Keep up the good work. Please make sure to get on to Math Excel and complete PCQ number 2. That is due Wednesday, March 7th by 11:59 p.m. Please contact me if you have any questions. Adios amigos, take care. Bye.